Right, so we're looking at some transformations. Remember, in the exams you are allowed to request and use tracing paper when it comes to rotations. We look at those, how to do that when we get to them. Right, so the first one we've got here. Draw the image of the triangle A after a translation of -3 units in the x direction and 4 in the y direction. Now a translation means that that shape does not turn at all. It just stays in exactly the same orientation but moves. Each point will move -3 in the x direction, so that point there is going to go 1, 2, 3 in the x direction, and then 4 plus 4 would be up the scale 1, 2, 3, 4 in the y direction. So that point ends up there. This point 1, 2, 3, 1, 2, 3, 4 will be there, and finally this point 1, 2, 3, 1, 2, 3, 4 will be there. Join those dots. And label the image B. So to look at, it's exactly the same, it's just changed its position. Part B, now we've got a rotation, and there are 3 instructions they need to give you to rotate it. First of all, the angle that is being rotated through, so this is 90 degrees, which is a quarter of a turn. Then it has to say whether it's turning in an anti-clockwise or a clockwise direction. And it also needs to tell you where you're centering your rotation from, and that's where the tracing paper comes in handy. So what we're going to do, here's our tracing paper. If we just trace over our shape where it's positioned now, and put a little arrow so we know where is vertically upwards. Now, if we're turning this 90 degrees clockwise, that means it's going to be turning a quarter of a turn in that direction. So we don't stop turning until that arrow is pointing directly to the right. And the point of rotation -2, 1 is where we're pivoting our turn from. So again, this is why it's really handy to have the tracing paper, because if you push that in, then the tracing paper will now turn from there. So we're turning this until we're at a point where the arrow is pointing right, which is there. Stop there. So this is the position of our shape. So if we just mark that in, there, and there, and there. So those are the 3 points for this shape, and label the image D. Question 2. Draw the image of the triangle after a reflection in the line y equals x. So the line y equals x is the line that's produced by the coordinates, where the x coordinate and the y coordinate are the same. So 1, 1, 2, 2, 3, 3, and so on. So if we draw that line onto our graph to start with, why is this so difficult? There we go. So that's the line y equals x. Now, I find the easiest way to work with this now is to turn y equals x so that's vertically upwards, and then work out each point, how far it is travelling at right angles to the line y equals x. So this point here is 1 diagonal across a square and a half a diagonal. See it? So that point, this side of the mirror is 1.5 diagonals, so it has to be the same the other side of the mirror. Half and 1 is there. So that point is going to end up there. This point is 1 diagonal from the mirror line, so that's going to end up there. And this point is travelling the other way, 1.5. So that's going to end up there. Then join up your points. And there's your image B. And again, if you hold that vertically, you'll see that that shape is symmetrical about that mirror line. It's harder to see that when you have your mirror line at an angle like that. Okay, B, rotate the triangle through 90 degrees. So it's 90 degrees, it's anti-clockwise this time, and it's about the point 2, 1. So get your tracing paper, trace your shape. Put a little arrow on, there's going to be a reference, and the point 2, 1, which is going to be where you're going to pivot it about. Now if it's 90 degrees, quarter of a turn anti-clockwise, this time we're going to be rotating it until that arrow is pointing left. So here we go, pivot on 2, 1, turn, turn, turn. That was a bit pointless with a left-handed person, but there you can see that's where it ends up. So mark that underneath the tracing paper, there, there, and there. And label it D. Good. Okay, here we got another reflection, but this time it's in the line y equals minus x. So the line y equals minus x goes through minus 1, 1, minus 2, 2, and so on. So it's diagonal going in this direction. So that's the line y equals minus x. And as before, I tip that vertical and then I count diagonals. So that point is going 1.5 diagonals, so it's going to end up there. This point is going 1.5 diagonals, so it's going to end up there. And that is touching the mirror line, so it will remain touching the mirror line. So there's B. A rotation. Rotate the shape through 90, quarter of a turn, anti-clockwise, about the point 1, minus 2. So cover your shape, trace it, little arrow. I go a quarter of a turn anti-clockwise, so I need to turn it until the arrow is pointing completely left. And I'm going to pivot around 1, minus 2. So if I can keep my hand out of the way, it is there. Okay, that's completely turned. So there's my shape. Number 4, we've got a reflection in the line y equals minus 1. So that is where the mirror is going on the point where every y coordinate is minus 1, which is here. That's the line y equals minus 1. And again, the perpendicular distance between every point in that triangle, this side of the mirror line, has to be exactly the same on the other side. So that point there, which is 1, 2, 3 squares away, will be 1, 2, 3 squares away the other side, which means that is going to go like that. And then this is 1, 2, 3, 1, 2, 3. So the shape is going to look like that. So that's a reflection. This is a translation, which is like the very first one we did. The shape doesn't change its orientation. It's just going to move, every point is going to move 4 to the left and 2 down. So this corner here will go 4, 1, 2, 3, 4 to the left and 2 down, 1, 2. So that one ends up there, which means the shape is going to go like this and then like that. So every point, that point, 1, 2, 3, 4, 1, 2. So with this enlargement now, with this transformation, this is an enlargement, and the way this one works is we've got a scale factor of 3 and a center of O. So the enlargement is whatever the distance is from the center of enlargement to the shape would be 3 times that distance on the enlargement. So to get from O to there is 2 squares, so on the enlargement would be 6. 1, 2, 3, 4, 5, 6. So the shape is going to start there, and then everything is going to be 3 times bigger. So it's going to be 3 times as big that way. It's going to go down 3 that way. Then that's 3, so we're going to go 9 down here. 3, 6, 9. It's going to be 9 across. 3, 6, 9, and then the diagonal. It's going to join up like that. So work out from the center 3 times as far, 2 distance there, so 3 times 2 is 6, so it's going to begin there, and then your shape is going to be 3 times as large as the original. Right, with this one now, we've got a scale factor of 1/2. So what we're actually doing, although it's called an enlargement, is we're actually reducing the size of it. Same as the previous one, we're using 0, 0 as the center of our enlargement. So in order to get from 0, 0 to S, we're going to go across 6 and up 6. So on our enlargement, the scale factor is 1/2 of that, so it's going to start at 3, 3. So S is going to end up there, and then SR is 6. So in the enlargement, it's going to become 3, and then it's going to become, this distance is 4, so it's going to be 2 and 2. So our enlargement is there. So same as the previous one, where's our origin? What have we got to do to get from our origin to the shape? Multiply that by the scale factor to get the starting point for the enlargement. So that was 6, 6. Half of 6, 6 is 3, 3. And then everything is halved from there. Same with this one. Enlarge the triangle, center 0, 0, scale factor of 1/2. So here we're going 6, 8. So the enlargement is going to go 3, 4. So it's going to start there. That base is 4, so in the enlargement it's going to be 1/2 of that. And this is 1, 2, 3, 4, 5, 6. So in the enlargement is going to be 3. Again, in the exam, you use a pencil and a ruler. Don't draw it freehand. Here we've got a rotation. So it's 90 degrees, it's clockwise, and it's got a center to 0. So cover my shape, trace it, put my reference arrow on. So this is 90 degrees clockwise, so it's going to rotate in that direction, quarter of a turn, so the arrow should be pointing completely to the right. The center of rotation is 2, 0, which is there. So let's get this turning and stop there. So that is where the shape ends up. Going to look like that. Bottom question. The diagram below shows a teacher's sketch of a transformation. What type of transformation is it? So this is the transformation where it hasn't changed its position, its orientation at all. It's just changed its position. So it's a translation. Okay, so with this one, point A becomes point P, and from one that we did earlier, you should fairly quickly see that what we've got there is a reflection in that line. Yeah, A is a diagonal from it, P is an opposite diagonal from it, so it's a reflection. And that line is known as the line y equals minus x. Rotation, retreat, 90 degrees, anti-clockwise, center point. Okay, so trace the shape. On your reference arrow, quarter of a turn anti-clockwise means it's going to end up the arrow turning completely left. Minus 1, 1 is there, so let's turn that, stop there, and there's where it ends up. So we've got from there to there to there. Label the image E. Okay, number 9A. Describe fully the transformation that transforms ABCD onto rectangle KLMN. So you can see there that the orientation is exactly the same. So it's a translation. And in order to get from A to K, it's gone 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2. Minus 8 in the X direction, plus 2 in the Y direction. In the higher tier, we could also write that as a vector. As a vector, it would look like this. Minus 8 would be on top, plus 2, and we'd write it like that. Rotate the angle the rectangle ABCD through 180 degrees. Well, 180 degrees is a full half turn, so it doesn't matter which direction you turn it in. So the arrow, if it's pointing up, we keep turning until it points down, about the point 1 minus 2, which is there. So we turn that completely. It's now hiding behind the hand until the arrow is pointing directly downwards. So it's going to go there. Like that. Reflect A, B, C, D in the line y equals x. So you need to put your y equals x line on your grid. So there's y equals x, and as I said earlier, I tend to turn that so it's vertical and then count diagonals. So A is 1, 2 and a half, half, 1, 2. So A ends up there. D, 1, 2, 3 and a half, half, 1, 2, 3. B, 1, 2, 3, 4 and a half, half, 1, 2, 3, 4. And you can see there what happens to the shape. Okay, and again, if you hold it that way, you can see that you've got that symmetry in the reflection. Right. Diagram on the grid below shows the translation of triangle PQR. So this is where it starts and this is where it ends. And this time they want us to give it in vector form. So in vector form, what we've got is the horizontal movement on top and the vertical movement on the bottom of the bracket. So let's work it out for P then. So P is going to move 1, 2, 3, 4, 5, 6, and vertically it's going to move 1, 2, 3, 4, 5, 6, 7, 8. So the translation in vector form is 6, 8. I need to zoom out a little bit. Just to take a look at these final couple. So what we've got here is triangle ABC. So this is where it starts, and A1, B1, C1, which is what it becomes. And we have to find the single transformation which takes triangle ABC to triangle A1, B1, C1. So it's been enlarged and it's been rotated, but we need to be able to write that as one translation. So we can't say it's been enlarged by and rotated through, because that's more than one. So an enlargement that has also turned around has got a negative scale factor. And if we need to work out where the enlargement has gone through, what we do is we join up the corresponding corners. So we know that A and A dot match, B and B dot correspond, and C and C dot correspond. And they should all pass through one point. Okay, so there's our centre of enlargement. The size of this, if you look there, it's been enlarged by, it's gone from 2 to 1, 2, 3, 4. So the enlargement is doubled in size, and because it's also turned 180 degrees. It's an enlargement with a scale factor of -2. Okay, if it wasn't minus, it would still be facing the other way, and the center of it is 3, 1. Alright, so if it's a single transformation, join the corresponding corners together. If it's upside down, then there's a negative scale factor. If it's larger, it's bigger than 1, a negative. If it's a reduction, smaller than 1, a negative. And where all the lines intersect is where the centre of enlargement is. So finally, a similar one again. Diagram shows those shapes, and we have to write a single transformation. Well, we can see the same thing has happened again. It's upside down, so it's a negative enlargement. And what we then need to work out is what the scale factor is and where the centre is. So if we take a look, DE has got a size of 2, and D dash E dash has got a size of 1, 2, 3, 4, 5, 6. So it's got a scale factor of enlargement factor of 3. Because it's been inverted, it's a negative scale factor. So enlargement of -3. And to work out where the centre is now, we need to join up our corresponding sides, corners. So A and A dash correspond. B and B dash correspond. So we can see where it's going to be. We'll do one more just to make sure. If we do E and the E dash, we can see that the center is 1, 4. And that pretty much covers all the higher tier sorts of transformations that you could be asked to deal with.